Hello, everyone. Welcome to the fifth session of the Test Automation Carnival, ensuring data quality with TQ. Today on the panel, we have Ramsha Abed, Aksam Ali, Mohammad Rizwan, and Jahanzeb Ahmed, who are going to talk about the issues of data quality and how they can be resolved using TQ. So today we are going to have a little change in protocol. So the audience is actually encouraged to ask questions during the session, but when you do, please say your name before answering the questions for record keeping sake. So let's quickly move towards today's session. Jahanzeb Ahmed will be presenting first. So over to you, Jahanzeb.
Thank you, Tajalli. Okay, let's start. Hi everyone, I'm Jahan Zeb. I have with me Ramsha, Rizwan, and Aksam, and Baba Javed is our mentor from TSA. Our presentation is on ensuring data quality with DQ. Let's move towards the agenda. Okay, so guys, data testing or big data testing automation is relatively a new concept when we compare it with web or mobile automation testing. And keeping that in mind, we have kept our session as simple as we can so that most of the audience can get benefit. So let me turn on the pointer. Okay, so our session flow will be that we'll start with the overview of big data. Uh, and how it help in transforming businesses. After that comes our problem statement and its possible solution, which brings us to DQ, the library, which is the primary focus of our session. We will then present a demo and move towards the conclusion and next steps. Okay, okay, for the next slides, I would like Rizwan to continue.
Uh, Thank you, Janzeb. Assalamu alaikum, everyone. This is Rizwan, and I'll be talking about big data and its benefits and forms of data, etc., and what is the problem and what is the solution that we have found. And so let's start with big data. So, what is big data? Big data is a term that is used for huge and enormous amount of data. But it's not the data that is important, it's what the organizations do with the data. For example, big data can be analyzed for the insights that lead to better decision making and strategy. Uh, as I talked about decision making and strategy, I'll be quoting a famous example that was also quoted by Forbes, Economic Times, etc. That they said that on the weekends, mostly fathers had to take care of the baby in the US, and they used to buy drinks and diapers together. Like why they did that? Because when they went to the Walmart, it was weekend. So first thing for the baby, they needed diaper for, and because it was weekend, so they needed beers or drinks as well. So when Walmart analyzed their data, they found the pattern that whenever a male customers comes in, most of the time they buy drinks and diapers together. So what they did was they put diapers and drinks together, and the basis of this decision, their sales went up and they had huge profits. And some data says that they had around $300 million increase in the profits. So that's how the impact of big data is. So moving on, I'll be talking about forms of data. Okay. There are primarily three forms of data: structured data, unstructured data, and semi-structured data. So, structured data is the easiest to search and organize because it is usually contained in rows and columns. And simply put, we can say that data which is labeled is structured data. For example, data stored in DB in which columns are labeled, etc. So, in this session, we'll be working on the structured data. So, what is unstructured data? Unstructured data is the data that cannot be contained in row column database. Like I said, in the structured data, the data is labeled. In unstructured data, data is not labeled at all. And examples would be audios, videos, etc. Uh, the third type is semi-structured data. Like it's the mix of both of it. Like the type of data defined as semi-structured data has some defining or consistent characteristics but doesn't conform to a structure as rigid as expected with relational database, that is like structured data. And examples would be like data in XML files, etc. So moving on, uh, like, like what are the benefits of big data? Big data can be important for various reasons. As they say that big data is the new oil of the digital economy. And for those who see data as fundamental value and learn to extract and use it, there will be huge rewards for them. And following a few of the benefits of big data, like big data can be important in business transformations. For example, big data analytics supports businesses to reshape their interactions with customer, market products more effectively, and drive more revenue. As I mentioned in the example of Walmart, the business was they uh, drive more revenue from just one decision. Next is the cost saving. Big data tools help to identify most efficient ways to do the business, and hence it helps in cost saving. Uh, Big data can also help you in time reductions. Like the high speed of big data tools quickly identify the data source, and hence decision making gets fast as well. And big data tools can also help you understand the market conditions. Like by analyzing the data, you can easily take the decisions according to the market conditions. And you can also control your online reputation, because big data can also do sentiment analysis, and you can get the feedback about your company. And if you are a big business, you can grow even bigger. So these are some of the examples of what big data can do. There are many more as well. So moving on. Okay. So what are the dimensions on the basis of which data quality is measured? First one would be completeness. Like your data should be complete. Your data should not have any null value in it. Next one is consistency. Like your data should be consistent. Like if it was giving some specific results yesterday, it should be giving the same or almost similar results today as well. So that's what consistency of the data is. Accuracy means how correct your data is, and uniqueness would be that your data should be unique. Like it should not have any duplicate values in it. And next one is validity. Validity means that data is according to the defined rules. If data is meant to be numeric and there is some set range, and your data breaks this range, then this means that your data is not valid. So these are some of the dimensions of the data quality. And okay, moving on. So okay, so what if your data is wrong? Like if missing or incomplete data can impact the decision makings. You had to take the decision A on the basis of some data, and if your data is wrong, you will be you're taking a decision B, which will be ultimately affecting your business. So this is one of the examples. There could be many more that if your data is wrong. So, problem. Moving on, we'll be talking about the problem solution. Uh, the problem was first solved by a manual approach. Like the teams used to do sample data comparisons between source and target manually, and also they checked that primary key column is not null, or your date column should not be null, and many other approaches. But this is a manual approach, and it is error prone, and it takes more time, so it becomes tedious as well at times. So there was a pressing need that there should be automation of data validation. So for automation of data validation purpose, we are using the DQ library, and I think Jahanzeb would be giving you the overview of what the DQ is and how how it solved our problem of data validation. So over to you, Jahanzeb.
Rizwan?
Yes.
Hi Rizwan, this is Asim here. So I have a couple of questions around what you presented.
Okay.
So if we talk about structural and unstructured data, so can you please give a couple of examples like what could be structured and what could be unstructured data?
I think I gave the example. Can Jahanzeb, can you move back to that slide again?
So if I talk about more specifically, usually we have data in JSON and XML form. So what do you think those are unstructured data or semi-structured or structured? What kind of data it could be?
In the JSON form, I would say it would be semi-structured data because it has some structure, but it's not. It doesn't exactly follows that. It cannot be binded to what we can say. I think for the JSON, it would be semi-structured data because it has some structure as well, but it doesn't conform to. You can say exactly structure as rigid structure as expected with the relational database. Like in the relational database, you have a data that is labeled as well. So in semi-structured data is not that labeled. It has some structure, but it doesn't conform to. It is not as rigid as expected with the databases, etc. So I think it answers your question.
Okay, thank you.
Okay. So you can continue, Janjay, I guess, if anyone else doesn't have any question.
Jahanzeb, you are on mute.
It automatically muted me. Sorry, thank you, Rizwan, for explaining the big data and how it can help us transform business. Yes, GQ is a library built on top of Apache Spark. It provides an automated way to test our data. As it is built on Spark, so it is generally designed to scale with large data and is lightning fast. If you see the diagram, you can see that user just need to apply some constraint. Based on those constraints, DQ will provide us the results or reports on our provided data. So DQ has three functionalities mainly: matrix computation, constraint suggestion, and constraint verification. In matrix computation, we use this to calculate data quality metrics on our data set. Basically, it's the statistics we use to compare or track in different sprints or something like that. For the constraint suggestions, it is used to profile the data to infer useful constraints, and we can use those useful constraints uh, and apply those to verify our data on those constraints and get the report. So we'll talk about these three in the next slides as well and in the demo. So moving to the next slide. So as GQ is built on Apache Spark, I will explain some information about the Spark and loading data into it. So Apache Spark is basically a framework for big data and has various advantages over other big data solutions. It is one of the largest open source project in data processing. Apache Spark is the most advanced and popular product of Apache community that can work on both structured and unstructured data, like dealing with graphs and stuff. And for data, the test data needs to be loaded in Spark, and we can load it directly from database or S3. This is for the structured data, as Rizwan earlier mentioned. For this session, we will be using the database MySQL DB set up on my local host. The best part is you don't need to know Spark in detail to use DQ. Okay, moving to does anybody have any questions in DQ or in Spark?
So yes, I have Abdul Maroof here. So you have written here we can have directly data from datasets to Spark dataset or from S3. Can we have real time data as well? So like the streaming data, the data that is coming on real time. These points are pointing towards distinct data, but can we have real time data as well here? This is my question.
Yeah, we have mentioned that in the future slides as well. Basically, Spark does not allow the real-time data, but it provides us a mechanism to have near real-time data but the data is distributed into the batches, and each batch is individually executed. So it does not support, I can say, the real-time data, but it has a features path stream for handling that. I hope it answers your questions.
Jahangir, I have one question related to it. So, do you want to answer it right now, or you want to cover it in the next slides?
Let's have it in the last slides. Basically, we have added the advanced features in the next steps that we will be going to perform in data testing. Basically, this is the basics of the data testing that we have started with. So we can have this discussion in the later slides.
Sure, thank you.
Moving towards the features of the DQ. First, we have the matrix computation. Matrix computation means to calculate statistics on data. It is useful to assess, compare, and track statistics of data. Basically, this is the result that we have added here after the matrix computation on our sample data. Basically, we have taken a sample data from the internet from another article, and we are using that data in our SQL DB, and after applying some metrics computation on that data, this is the result that we get. So we have checked the minimum, mean, and maximum value on credit limit that we have, that we can compare or track in the future sprints or testing as well. And this was the size of the data that we have provided or loaded into the Spark. So yeah, this is just for the just to calculate the statistics on data. For the next constraint suggestion and verification, I would request Aksam to continue.
Okay, so everyone, Aksam here. So I will be talking about constraint suggestion and constraint verification. So this is the most important part in the DQ. So first of all, let's talk about the constraint suggestion. So the main challenge is to define the appropriate constraint manually, because in the unstructured or semi-structured data, there are no labels, and you cannot identify the constraint while viewing the data. You cannot guess the data constraint from just viewing the data. Example of that is, if in a structured data, since there are labels, for example, there is a text ID or there is some sort of ID. So you can guess that the ID should be unique or it should not be null. So based on that thing, you can identify two constraints from here. That one is it should be unique, and second one is it should not be null. So based on that, DQ will suggest constraint. But the main challenge is for the unstructured or semi-structured data. But the main hurdle that we have in DQ is it just supports the tabular data. So that's why we're using the structured data here. So while DQ, the input is a single table data set, which with not defined the type info or any schema information about the table. So what DQ does, it then profile the data in a phases. In the first phase, it will compute the data. It will compute the data size. Then it will run the data type detection, on the basis of which it will detect whether it is a numeric, it is an alphanumeric, or what sort of data is it. Then it will compute the completeness of the data. Completeness means there should not be any null values, or if there is null values, then on the basis of this completeness, DQ will suggest some constraints. Then it also suggests the number of distinct values. So this is what is done in the first phase. While in the second phase of the profiling, then we are calculating the min, max, mean, standard deviation, or the correlation. Okay, so the term correlation defines in the way that if one entity is increasing, then on the basis of this, the other entity that is attached with it will also increase. As an example, you can say if the experience of an employee is increasing, it means its base salary will also be increasing. So this is how the terms or the columns are correlated. If one is decreasing, the other will also decrease. So on the basis of this profiling, then DQ will suggest some constraints. There could be for the if there is data does not contain any null value, then the constraint suggested will be is complete. If their data contains null values, then constraint suggested will be has complete. Okay, so from the diagram that is being you can see in the slide, the constraint that is being suggested for the address line 1 is complete. It means the address line 1 should not be null. For the city is complete. It means it should not be null. And similarly for the rest of the constraints that are being suggested from the data that we are using. Okay, let's moving forward to the constraint verifications. So once the constraints are being suggested by the DQ, you have to now apply the checks for the constraint verification. Now there is no such restriction that you will be using all the constraints. It entirely depends on your choice what constraints seems to be very important for your data. Based on the constraints you want to apply for your data, you will be picking those constraints, and then there is a DQ class which provides you analyzing those constraints, and you can add these constraints in a check class. You will be adding them as in the form of checks. So if you will be applying then is complete, and you will be providing the parameter as an address line 1, and if it passes, if there is like no null value in the address line 1, then DQ will pass this constraint and will tell you that data quality is ensured here. And if there is some sort of null values in the address line or in the city for which we have defined that there should not be any null value, then DQ will fail that constraint and will tell you that there is some wrong with this data. So based on this, we are maintaining or ensuring the quality of the data that you will also see in the demo. So I will request Jahazeb to move forward with the demo and show you how these constraints are suggested and then how the verification is performed.
Jahazeb, you are on mute.
Okay, thank you, Exam. Guys, I'll quickly, I'm showing you the SQL database that we are using in our session. Let me run this query. Basically, we have a classic models database and customers table that we'll be using in our demo. It has some records and it has 122 records, right? So let me move towards the demo. So basically, we have this command line open in administrative mode. We just write Spark shell to open the Spark shell where we can write our Scala code directly. And another way is that we have written the code in separate files. We can load these files directly into the Spark, and that can execute each line and provide the result. So basically, this is the code for the database connection. First thing we need to do is to load data into the Spark, into Spark. So for that, we are importing Spark, SQL context from Spark and creating an object of SQL context. Then what we are doing is using that context, we are reading, making a connection, JDBC connection with our local database. Then this is the driver used for the JDBC connection. Then we are mentioning our data table, username, password, and then we are loading this data into our data source. This will be an object of Spark, and then we are printing the schema loaded in that data source. So let me load this file. It has a simple syntax that colon load, and then we have to give the path of the file. So it is executing the code written in that file line by line, the import of SQL context, then SQL context object, then executing and saving the data in the data source, then printing that data source. So I have used root, and this is the data. Sorry, I have this is the root, and this is all the data that was stored in the customer table. So moving on, I have the data loaded in a data source object named data source. Next step would be to compute the matrix computation. I'll quickly go through the code, and then I'll load this file in the Spark shell in a similar manner. So what we are doing here is to compute matrices. We are using DQ library, and we are getting the analysis runner and context. And then from the analyzer context, we are using a success matrix as data frame to convert our result, analysis result, into Spark data frame that would be easier to display on the command line. And here we have some analyzers from the DQ, like correlation, size, completeness, mean, maximum, minimum. There are many others, but we are using some of them in our session. So we are mentioning the data source that we are going to run our analysis on. Then we are adding some analyzers like size, what is the size of the data, then completeness on customer number, then approximate count distance on customer number, then minimum, mean, and maximum on credit limit, entropy on credit limit. Then we are going to run this simple. Once this is run, as I mentioned earlier, that we'll load this analysis result as a Spark data frame named statistics, and will show that. So I'm going to run this file. So it executes line by line from the matrix computation and will print the result. So this is the result it has provided us for our given our applied analysis, that customer number completeness is 1, that is then approximate count distance is 199, the overall size was 122, and credit limit, mean, maximum, mode, and entropy. So this is how we write the code. These are the simple application of the matrix computation and DB connection. For the next constraint suggestion and constraint verification, I would request Aksam to continue. Before that, if anybody has any questions for me, please go ahead. Aksam, can you please start?
Okay, so there are questions from Yasir. So should we answer that first, or should we go for the constraint suggestion first?
It's in the chat. I have
Yeah, I've some,
Yeah,
get
it's
it.
in
yeah,
the chat.
I have pasted some questions in the chat. It depends on you if you would like to answer them right now or
I
going
think
forward.
this is not related exactly with the current slides, so I think we can have it in the end.
The question number 4 is actually related to the current slides
Okay,
regarding
what
the
do we get to
mathematical.
know from the matrix computed? Basically, this, as I mentioned in the slide, this is the statistics that we get on our data. Basically, when you perform a data testing on some data, you have a different source and target. So once we move the core data from the source to our target location on where we are going to perform our data testing, it is important to know that the data is not missed or changed, or there is no bad data in it. So it can be helpful to compute some metrics on the source, then run same analysis on the target location and compare both to see if there are any bad data in it.
So the computations need to be run on a sample data set. Since you mentioned that the code runs row by row, assuming that
Uh,
we are running it on a big data, so there would be billions of rows. That were gonna take a lot of time.
no, I was mentioning that when I said that it executes row by row, I meant that this is one instruction, the import. Then this is the second instruction. So one instruction is entered in the Spark shell at a time. So this one is a single instruction, and this executes in parallel. Basically, this is the these brackets mention it is a single statement. I have added next lines in the code. Basically, if I had to write it in a single line, then I can omit these brackets as well. So this is a single instruction, and it runs parallelly on the data.
Right. Actually, what I wanted to know from these metrics or the measures, we get some numbers, right? So, what do these numbers mean? Like, for instance, if the completeness returns, like, for instance, like in a number format, like from, like here, it says 1. So, what does it mean?
One means it is complete, and less than one means the ratio in which it is not complete. Aksam?
Yeah, it's like for the completeness, you can set the value from 0 to 1, where 0 means the data is entirely not complete, it is all null. It basically gives you an idea of how you will set the parameters for the completeness. If you are setting the value to be 0.5, which is the bare minimum for you, that data should 50% should be complete, and it could be 50% incomplete. So this is how this matrix computation is giving the idea. So, like if you are getting the entropy or the correlation to be 1, it means the data is highly correlated, which means if there is changing in one column, it will change the other. So, you should know how to deal with such kind of data. And also for the main max, these basically are helping you in your constraint suggestion or verification part, how you are going to deal with your data at the end of the day. Like
Right. The
you have
min-max
seen the
actually.
completeness.
Mm-hmm. Yeah, please continue.
Let me Yeah, so like you were saying here, the completeness is 1, and in case when you execute your constraint verification part on the data, and it turns out that the completeness is 0.9 somehow after the injection of new data, so it means there is something broken there, and you will know that that data is bad there. There is some sort of incomplete data there. So this is how the matrix computation is helping you.
Right, right. Thank you so much for that. And I was also worried about since you mentioned that there shouldn't be any null values in the dataset. So do we need to like prep the dataset before feeding it to the DQ?
You are asking about like
Actually, you mentioned somewhere in the session that there shouldn't be a lot of or somewhat null values in the dataset because they would gonna cause the completeness of the dataset. So the
no,
DQ,
they put. Let me answer. Okay, sorry. You can go ahead. Complete your question then.
yeah. So the DQ is also responsible to handle out the null values by itself, or the user needs to prepare the dataset before feeding it to the DQ.
Okay, so we are basically injecting a raw data in the DQ. So DQ will, there is a constraint, there are two constraints to check for the null values or for the not null values. So if you are applying the constraint is complete, okay, through the DQ, which means the data should not contain any null values. It entirely depends upon you. If the, let's suppose I want that the ID of a customer should not be null in my data, the data I'm injecting in the pipeline. So you will apply is complete. And if you know there could be any null values, there could be null values there in the data, you know, the data type, so you will be applying has complete, which means you are allowing the data to have null values there. Like you can see in the sale receipt, there could be null values in the sale receipt, and we are applying the constraint has complete. It means if null value came out, the then DQ will not fail the data there. It will not prompt anything because you are allowing it to contain null data. So the for the question part, you do not need to prepare any raw data. So you will be injecting the raw data, and then the constraint will be suggested on that, and you will then apply those constraints.
So on the basis of, for instance, if we have huge tables, we need to define, or we need to inform the DQ that for every column, this is the data type, and this would be the requirement that this column shouldn't contain any nulls, or it should contain any nulls. On the basis of that, it defines that it should be complete or it shouldn't be complete, right?
Yeah. So the first like for the constraint suggestion part, DQ is facilitating you in that manner. It will facilitate you in suggesting the constraints, and then you will be applying those constraints based on the importance of the data on the columns that you seem to be very important for.
Right. So is there any like automated rule in the DQ library for that, or the user manually needs to define for each of the column of the table?
Okay,
Like
so
for
you are
instance,
writing the unit test cases. Yeah. So first the constraint will be suggested, and then you'll be writing your own unit test cases based on those constraints. If you have your own constraints besides the suggested one, you can apply also that, given they are being facilitated by the DQ library.
Yasir, I have something. A DQ doesn't provide you the way to clean up the raw data. You need to clean it yourself. It can analyze your raw data and suggest you a situation or constraint that are missing in the data. Like if you have a column that doesn't have any null value, then DQ can suggest you that you should apply a no null constraint on this column. So DQ doesn't do any cleanup process. That process should have be done by other team. It's just verifying the data.
right. Thank you, Baba. Thank you. Understood.
Okay, so moving, if there are any other questions, you can ask now, or I will move towards constraint suggestion part. Okay, so let's move towards the constraint suggestion part. So DQ provides you a class that is constraint suggestion runner class, on which providing the rules. So you will apply on your dataset, the dataset you are providing, and then on the basis of this, it will then give you some suggestions. So Jazim, can you execute this file in the command line so we can see how the DQ is suggesting us the constraint on the dataset?
Aksam, you are on mute.
Yeah. So okay. So we have executed the file, and you can see the constraints that are suggested by the DQ on the dataset that we have provided. So based on the data set it is providing you is complete, is unique. It entirely depends on the data type and on the like is DQ which is suggesting you these constraints. So well, you can see for the address line one, it should is complete, which means uh, there should not be any null values. And for postal code, we can see it is providing you has completeness. It means it could contain null values. So you know that there could be null values in the postal code. And for instance here, if you apply is completeness on the postal code, it means that constraint will fail at the end of the day, because you are instructing the DQ that postal code should not contain any null values, while DQ is suggesting that it contains null values. So this is how DQ is working for the constraint suggestion part. So once the constraints are suggested, we will move towards the verification of these constraints. So I will request Jahazeb to show you the constraint verification file. Yeah, so in the constraint verification file, so DQ is providing you with a number of libraries like verification suite, then verification results, and on the verification results we are seeing check result as data frame, and then there checks class. So we will apply these checks on the data source. I have applied a few constraints that seems to be very important. That is, the data set should be of size 122, and if you are going to change this size to 123, the constraint will fail. So from Yasi, you can see we calculated the metrics, and it provided us that the data source contains 122 data values. So that's on the basis of this, which are basis of that value, we are suggesting a verifying constraint here, and is complete and is unique and is non-negative. These are all the constraints. That means the credit limit should not be in a negative value, and the customer name should be unique. It should not contain any duplicates, and is complete, which means should not be null. So Jahazeb, you can execute this file, and we can see whether the constraints pass or fail. Okay, so at the end of the computation of this file, you will see. So now the check is data validation constraint. The check level is error, which means if there is some sort of error, it should fail. The check status is success. So the constraint was size constraint, which means we have defined that the size should be 122, and it was correct. So constraint status is success. It has passed, and for also the completeness, it is success, and for the uniqueness and also for the compliance, it is success. So if you want to get a failure status, you can just change any value. Like you can change the size of the constraint to 123 or someone less. And if you want to fail any, like it entirely depends how you are validating with your data. So that's pretty much it with the constraint verification part, which is the most important part with your data, in which you will now you can check from this if your data is valid or not. So let's move towards Jahazeb to conclude this presentation.
So basically, that was all about the demo and the explanation before that. Then comes the limitations of Spark. Basically, nothing comes without a price. So we have a few limitations of Spark as well. We'll mention some of them, like no support for real-time processing. Basically, in Spark streaming, the arriving live stream of data is divided into batches of the predefined interval, and each batch of data is treated individually. So basically, it is not a real time but near real time. So a basic difference you can say that the real time processing is a single job, whereas in Spark there are multiple batches that are handled individually and are treated as a multiple different separate jobs. So it does not support real-time processing. Then there is file management and small files. Basically, it has no file system of its own, Spark. So we are using Hadoop HDFS, Hadoop distributed file system. It provides limited number of large files rather than large number of small files. So if you have a lot of small files to load, basically each file will become partition. Uh, and if we want efficiency in our processing, the data should be repartitioned into small manageable format. This requires extensive shuffling over the network. So this is another limitation. The next is expensive. Basically, Spark performs in-memory computation. Uh, it can in-memory capability can be become a bottleneck when we want cost-efficient processing of big data, as keeping data in memory is quite expensive. The memory consumption is very high and it is not handled in the user-friendly manner. Basically, Apache Spark requires a lot of RAM to run in memory. Thus, the cost of Spark is quite high. So, moving to the next slide, we are added conclusion. Basically, although Spark has some drawbacks, it is still popular in the market for big data solutions. And Amazon is using DQ as well, and DQ purpose is to unit test data to ensure data integrity and find errors early before we take any business decision on the basis of our data. Also, concluding the slides, we have, as this is a new topic, data testing, we have also prepared getting started guide for DQ on Windows 10. I'll quickly show you that. The purpose to build this guide was it is inspired from the different articles over the internet, but they were outdated and not every article was mentioning the actual target or URLs where you can get the libraries or download the libraries or data. So basically we have prepared this for anyone who is interested to get hands on the data testing, automated data testing. So on the left navigation panel, I'll quickly go through the topics. We have mentioned some capabilities of DQ, then prerequisites. Requisites include Scala, Java, Apache Spark, data preparation. You can use your own data here, library, DQ library, and JDBC jar for the MySQL connection. Then how to start Spark, then the topics covered in our demo session as well, and then the conclusion that how it helps you set up Spark as well. So this would be available for everyone. After the conclusion, we have our next steps. Basically, this presentation or the purpose of this whole activity was to jump in the data automated data testing thing and to analyze what are we basically lacking. So there are a lot of next steps that we have added, like types of data sets and data sources in Spark SQL. Basically, every data that we load and play around in Spark is a data set. So we still have to identify how to save that data after the computation in another database or extract it into a file or something like that. Let me Okay, Spark streaming, how to handle data in streaming. Basically, streaming data is the unstructured data. It can be a form of audio, video, or different other files that keep coming in. After that, the data validation on incremental data using DQ. So DQ provides us data validation on incremental data that it automatically check the previous data with the new data. We do not have to compare the different computations or the statistics manually. It provides us a mechanism for that. Then anomaly detection. Parallel execution for data validation is something that DQ or Spark performs, but we still have to look into it. Then Apache Flink instead of Apache Spark. Basically, while working with Apache Spark, we came across Apache Flink and read that Apache Spark is considered as a 3G in big data solution, and Apache Flink is considered as 4G. like I mentioned earlier, that Apache Spark does not allow that. Apache Spark basically was not built for streaming data, and later module was added for the streaming data, and Apache Flink is based on the streaming data, and it is better for the streaming data. So going forward, we will have these items in our list to learn. And obviously the next slide is the questions. So we are done here. Thank you everyone for the patience, and please start with the questions. I will leave the next step slides open so that everyone can see this and add new questions. We'll note down the questions and add in our next steps if required, or answer those questions as appropriate.
So Yasser here, I have a question regarding the clusters in the Spark and the HDFS clusters. Is there any limitations on that topic too?
Yes,
like the size of the clusters?
We haven't worked with the clusters as yet. We have read about them, but we have not get hands on that.
Right. Since you mentioned that you guys have used the Hadoop file system, right? HDFS for this
yes.
thing. So the HDFS happens to have the cluster since it's a distributed file system, and there is some sort of limitations on the cluster size and things like that. So I believe that there might be some sort of limitations too in the testing area too.
I'm not sure I'm able to answer that.
Sorry, who's Yasser, what sort of limitations on the cluster size are there? Like, can you explain a bit more on HDFS side?
Yes, what I was worried about, it was mentioned in this session that there is some sort of limitations at the Spark end for the handling of the clusters.
I think it's
you're breaking up.
Sorry, I think they probably they mentioned the file size thing, right? The small file size thing, which is a problem with the HDFS, right?
Okay, so it's not based on the limitations on the cluster level, rather on the file system level, on the file size itself.
It's because the HDFS is, as they mentioned, it's basically built for handling large size,
yes, exactly.
large volume and the size thing, right? So it has a problem with the small file sizes. So I'm not sure how much you guys know about the architecture, but there is a big data week coming around end of June. So where we are presenting this HDFS architecture. But to be just on a brief side, so the problem is in case of HDFS, the files, like when you have a cluster, there is one master node which handles the metadata, and that metadata is maintained in memory, and that metadata basically determines where, or it knows, basically it's the metadata of the files where the files resides on the slave nodes, or which are called the data nodes. And then the files are further divided into the blocks. All that things are maintained in memory. So if you have a lot of small files, then that metadata size increases, and that put pressures on the master node memory.
And this is applicable for both mapper and the reducer part.
The MapReduce it doesn't. So the Spark is the difference between MapReduce and Spark is that Spark. I mean, the main problem with MapReduce was that after every steps, these results are written to a disk. So there's a lot of disk I/O resolve, which is inherently slow. And then, so for example, you have step 1, then results of step 1 are written to a disk, and then step 2 then reads from that step output of step 1 from the disk, and then do some processing and writes it back to the thing. So the way Spark solved it is it's basically put everything in memory. It brings everything in memory, so you don't have to write, save the cost of this disk IOs, and that's how it achieved all this performance. So that's how these is the thing. So that's the main difference, apart from like other the other differences as well. But this is the main thing. So so that's what they mentioned. Like it needs a lot of RAM because in memory, because whatever we're doing in MapReduce things, it's now bring it everything in memory. So the steps, like if step 1 doesn't have to write to disk, so it's basically directly can pass it to the step 2 and then stuff like that. So the problem with this small file sizes, like especially for in this problem with the streaming when you are doing streaming analytics, because the main idea of streaming is that it's a continuous stream of data, right? You don't know where your data ends and begins. So you at some point you have to, if you're writing files, like you're writing your output to some file system, you have to close the file, right, and then move on to the next one. So because you in streaming, you really don't know where you end, your data ends and then begins. So you decide, okay, something, and then you say, okay, I'll read these, let's say 1,000 messages and write them, and then I read next thousands and stuff. So this results in a lot of files. But there are certain strategies you can do that. You can even create one big file within Spark as well. It's not, yeah.
Thank you so much for the explanation.
I have one question. I think what you guys are saying is slightly regarding Spark is slightly outdated, in a sense that there is another API called structure streaming that's basically doesn't work in batches. So it's kind of, they're trying to catch up with Flink. And that's basically, I think, there for a year now. So at least where you're saying, like, it's near real time, and which has been like it's work in small batches.
Yes.
But you can now move to structure streaming.
Right.
Yeah. And I think if you want to move to Flink, I don't think, I mean, because DQ is built on top of Spark, so
Yes.
probably it won't work on with the Flink, because all these data sets and data frames concept is specific to Spark, and I think it's tightly integrated with that concept. So
yes, that was in our mind as well for Apache Flink. So we'll look for Spark R structured streaming as well. Thank you.
Do we have more questions? Do we have more jokes? Yeah, Asim, you promised a joke in this session.
So first I have a question. So basically, while we are talking about DQ, so do we have any other options available for this purpose? Do we have any comparisons with us? So for example, if we start a new project or a new research, should we start working with the DQ right away, or should we look into any other option as well?
This is not a funny joke. I don't know where to laugh.
ये आसिम भाई ने रुलाने के लिए पूछा.
Specifically for
Asim, coming back to your आपका question. अच्छा, ये तो Amazon की library है. Then there is a library called Griffin, which is from eBay. वो लोग एक library Griffin use करते हैं. Then एक library है, I think it's not a library, it's they're trying to build something on top of Spark as well, it's called Centrifuge. वो भी similarly this use होती है. But I think this the problem है कि because most of the जो probably 2-3 years ago जो big data world में लोग people have moved away from batch based systems to streaming systems. जो real time streaming analytics है उसकी तरफ ज़्यादा trend हो गया हुआ है, तो I'm not sure कि ये when you are getting live stream of data तो ये how can these libraries can help, because mostly जो इनकी यूज केसेस थे वही आपका वो ये था कि when you're moving data from static sources आपका जी data warehouse में data पड़ा हुआ है, you have customer relationship data management CMS में systems हैं, अब वो वहाँ से जब आप अपने data lakes में move करते हैं तो then probably there is obvious usefulness of these libraries, but probably I need to look more into these things, but मुझे I still haven't got my head around कि ये streaming के cases में how useful these can be, especially जब आपका एक mostly unstructured data होता है.
So is it not better to look into the Apache Flink as well and leave the library if need be?
Flink का जी ये भी है कि आपने मार्केट अडॉप्शन भी देखनी होती है. स्पार्क की अडॉप्शन ज़्यादा है. Flink डेफिनेटली स्ट्रीमिंग में लोग यूज़ कर रहे हैं, बट लाइक से अब हम वॉलमार्ट के केस में देखें तो वो दे आर स्टिल वो तो अभी स्पार्क से भी पिछले एक बिफोर स्पार्क देयर इज या इवन आप स्पार्क स्ट्रीमिंग या Flink से पहले देयर इज अ स्टॉर्म. ट्विटर ने एक सिस्टम बनाया था अपाची स्टॉर्म के नाम से फॉर रियल टाइम एनालिटिक्स, तो वो वहाँ तो अभी वही यूज़ हो रहा है. और ट्विटर जो है उन्होंने उसको डीकमीशन कर दिया एंड देन they came up with a better solution called Apache Heron, जो कि I think Flink से भी काफ़ी inspired था. And then they but market में जो लोग Storm के साथ फंस गए हुए हैं, I know a lot of companies, because that was the like before 2016 end of 2016 the only option you had was Apache Storm for real time. And once you are using one big data framework, it's not easy to migrate to the new one. API is different and concepts different and काफ़ी तो उसमें it's not that easy. Means even within Spark, like for example, what we're currently doing in Walmart is कि हम structure streaming से direct streaming or Spark streaming जो है उससे we are trying to move to structure streaming. और उसमें काफ़ी चीज़ें हैं. फॉर एग्जांपल हम जो कि फॉर ग्रांटेड लेते थे कि यार वी कैन डू दीज काइंड ऑफ थिंग्स फॉर कंबाइनिंग डाटा और प्ले विद द डाटा, वो वी कांट डू विद द स्ट्रक्चर स्ट्रीमिंग. तो वो मीन्स इवन विद इन आपको बताऊँ इन वन लाइब्रेरी वन फ्रेमवर्क अगर आप एक से दूसरे मूव कर रहे हैं तो फॉर एग्जांपल द बेसिक नोशन जी था कि you have a reducers, right, and you can say कि मेरी एक primary key I want to collect all the data with these primary key on one node. तो वो उसके equivalent जो है structure streaming ने they haven't given anything कि आप किस तरह करें ये चीज़ें. तो and then imagine कि आप एक structure आप Flink से या उससे move हो गए हैं. Then there is latestly, not recently, last year there was an initiative from Databricks, Data Artisan, जो कि Flink के हैं, and Google. So they are now defining a kind of a standard for stream all these streaming. So there's this called the project called Apache Beam, where they are जिस हम JDBC में हमने define कर दिया कि एक पूरा एक contract define कर दिया, किसी ने भी provider ने कोई JDBC connections देने हैं तो ये उनको interfaces implement करने होंगे, and these are the contracts how it will behave. So the Apache Beam is for equivalent for that for streaming. So let's see कि वो I know Flink is supporting that. Spark जो है they are saying they will support it in probably version 3.0. And then there is another couple of other, which is Akka streams. Akka ki streams, and they are already supporting that that interfaces. So let's see.
Thank you, Sir.
आसिम इसमें ये है कि अभी DQ है ना, it's the fastest to start with. ये इसमें काम करना जरा easy है compared to Apache Griffin.
ठीक है. My next question is for Aksam. Aksam, how are you?
I'm good. How are you?
Question answered.
That's a very nice question.
काफी देर से कमोड
यार इजी क्वेश्चंस करें, आप मुश्किल क्वेश्चंस करना शुरू हो गए यहाँ से। घरों में लोग बैठे हैं इतने दिनों से, कोई भी नहीं कह सकता देयर वेयर आई मीन एवरीबॉडी वांट्स टू गेट आउट। आसिम साहब, आप कैसे अभी तक घर में हैं? आप, मुझे लगता है कि हुंजा के 3-4 चक्कर लगा चुके होंगे।
बिल्कुल ऐसे ही है आसिम भाई, इस वीकेंड पे भी मैं सोच रहा हूँ इकट्ठे चलते हैं दोनों, क्योंकि मैरिड लोगों के लिए भी घर में बैठना कोई आसान काम तो नहीं है इतनी देर।
उनके लिए डबल जो है वो डिफिकल्ट है, लेकिन मुझे लग रहा है अभी जाने के चक्कर में हम किसी पुलिस स्टेशन में बंद ना पड़े हो कि आप लोग घर में बैठे कहाँ फेरे करें।
मेरा किसी से रिलेटेड एक क्वेश्चन था। सो व्हेन वी आर टॉकिंग अ लॉट अबाउट डेटा इन रेस्ट एंड डेटा इन फ्लो, सो देयर इज एन which we can say data in use. So where does it reside in this paradigm? So any thoughts around it?
Can you please explain data in REST and data in the other?
So data in REST mean you have archived some kind of data, so you can run your constraints and DQ on that. So data in use may be something like that, which is actively being used. It is identified by the current users of current applications, something like that.
I think the two terms, I think, were the data in motion and data in rest. So data in rest, basically the term is used for those sources of data, some data warehouses हम ला रहे हैं, मतलब Oracle entire data से है, या even आपका ERP system से है, CRM system से, when you are bringing that data, जो कि probably इतना frequently शायद update भी नहीं होगा, but even ये कि वो आपकी normally jobs जो हैं वो जिसमें बताया कोई bad jobs हैं वो end of date लेंगी, and then that bring the data into the lake. So those kind of just sources हैं उनको normally they are referred to as data in rest. Or data in motion is mostly these new streaming sources हैं, आपके IoT devices का data is IoT की world में, and you're getting those heartbeats and all this kind of, जिस तरह आपके social media से feeds आ रही हैं, that's everything, all these kind of things. Yeah. For if you're doing log analytics, तो उसमें आपके जो constantly logs की feeds आ रही होती हैं।
इसमें यही है कि obviously जो data in rest है उस पर तो ये काम कर ही रहा है। Data in motion के बारे में हमने discuss भी किया है कि it's our next step, how we can achieve it with DQ if it supports. Otherwise, we can explore some other tools for these type of testing.
So अगर मैं वेब की टर्म में बोलूँ ना, so you are the data scientist, so you know more about data science things. So अगर मैं वेब की टर्म में बोलूँ, there is another term, data in use. So I was talking about it specifically कि data in use भी data in motion में ही reside करता है data science की paradigm में, या this is something else?
मेरा ख्याल है शायद वो डाटा इन मोशन में रिजाइड नहीं करता, क्योंकि उसमें कोई डाटा रियल टाइम आ तो नहीं रहा, लेकिन सिर्फ यूज हो रहा है। वो डाटा इन रेस्ट में क्वालिफाई कर सकता है। मे बी इत्तेज़ाज़ साहब इसमें कुछ ऐड कर सकते
हैं। यार आसिफ साहब, मैं इधर अब हमें जो है ना पीछे छोड़ गए हैं गूगल सर्च में।
I can add it answer. Data in use is basically the active data which you are using. So it can relate to data in REST because it's the active data that you're using on your computer or processing system.
पहले तो आप अपना नाम बता दें प्लीज, क्योंकि लड़कियों की आवाज थोड़ी
Ramsha Abid. My name is Ramsha.
थैंक यू रमशा। सो इफ्तार साहब थोड़ा सा गो थ्रू किया था आगे से पहले, ज्यादा गूगल नहीं किया था तो
अच्छा, आप इसमें कुछ ऐड करना चाहिए? आसिफ ने वैसे आपसे पूछा था।
I think ये session में मैं लगभग ये join कर रहा, so I will look into more about it and then I will definitely come to you guys for all.
Definitely.
ठीक।
Anything else, anybody? Okay, तो जल्दी I think can conclude.
All right. Thank you everyone for joining us today. Thank you Aksam, Rizwan, Janzeb, and Ramsha for presenting today and discussing how issues of data quality can be tackled with DQ. On Monday, we have our 6th session and our last session for the Tech Automation Carnival, a robust unit testing for JS applications. Now, this session will be open to an external audience as well, and a form for that will be rolled out shortly that you can share with your friends or anyone who would be interested to attend this session. And the session will be conducted on Zoom. So let your friends know as soon as this form is rolled out. Thank you everyone for joining. The question of the day will be rolled out shortly as well. And that's it for today.
Thank you everyone for the participation.
I just want to add one note. So thank you team, thank you Babar and your team. So definitely it was a new field for the QA and they have done a great job. So it was a new learning opportunity for most of us as well. So thank you for the session.
Thank you.
You're welcome.
Thank you.